All right, hey everybody. So today is going to be our last lesson before we start graphing rational expressions, which is going to be super fun. We're going to have some really neat graphs, but we're going to be dealing with complex rationals. So remember that a rational expression, hey, is a fraction whose numerator and denominator contain polynomials, right? So expressions with x's in it. What makes a rational complex is when there's a rational expression within a rational expression, like a fraction within a fraction. So when we look at this problem, there are two fractions in the denominator and there's a fraction in the numerator. So I mean, there's fractions within fractions. That's why they're called complex. And I'm going to show you two different routes with this simple example here on things that we can do with complex fractions, complex rationals. So one thing I could do is I could say, well, if I'm taking this fraction, and remember a fraction is division, right? So if I'm taking this fraction and dividing it by this fraction, what I first could do is I could subtract these two fractions. I could get a common denominator, right, which would be 12. So this would be 2/3 divided by 9/12 minus 4/12, which is 2/3 divided by, let's see here, 5/12. And then we could remember this. Dividing is the same as multiplying by the reciprocal. So I could take 2/3 divided by 5/12 by taking 2/3 times 12/5. All right. So when we take one fraction divided by another, we know dividing is the same as multiplying by the reciprocal. So I changed 2/3 divided by 5/12 to 2/3 times 12/5. And let's just reduce this here a little bit, and we get 8/5. All right. Okay. So to do that, we needed to actually subtract the two fractions in the denominator, because changing division to multiplying by the reciprocal only works if it's a fraction divided by a fraction. So I do want to show you another route that we could take here, and it uses that LCD that we found so helpful, that least common denominator. When we take a look at the denominators of 3, 4, and 3, okay, the least common denominator of those would be 12. So what I'm going to do is I'm going to multiply the numerator and denominator by 12. All right. So when I do that, I take 2/3 times 12, which is, what is 2/3 times 12? 8. Okay. Now in the denominator, I need to distribute. I take 12 times 3/4, which is 9. 12 times 1/3, which is 4. So we end up with 8 over 9 minus 4, which is 8/5. And isn't that pretty slick? Okay, I think that's pretty easy. Okay, so the concept here is to multiply by 1 in the form of the LCD over the LCD. And the reason I say multiply by 1 is we multiplied by 12 over 12. See this? Okay, we really multiplied the whole fraction by 1. Okay, but it's of the form LCD over LCD. Or you could do multiplying by the reciprocal, but again, that's only if it's a fraction divided by a fraction. Okay. If it's something like this where we're subtracting two fractions in the denominator, you would have to subtract them first instead of using multiplying by the reciprocal. So when we take a look at this problem, okay, first thing that we want to do is we want to factor. Okay, and that has been something that we've been doing a lot lately, is factor right away. So this is x over, this is 3x plus 2 times 3x minus 2. Now here I do have a fraction divided by a fraction. So I can change this to multiplying by the reciprocal. Instead of taking x over 3x minus 2 divided by this, let's multiply by this is reciprocal. This is this reciprocal. 3x, uh-oh, board's glitching. Okay, so I changed this big division into multiplying, and I took the reciprocal of this one. Now we can see the x's cancel. We can see this 3x minus 2 cancels the 3x minus 2 there, and we end up with just 3x plus 2. Now, don't forget to state your excluded values. We are saying this equals that, but it doesn't for a few values that aren't able to be substituted into this. So what can't go in there? Well, x cannot equal 2/3, right? So here's a denominator, 2/3. I can't put 2/3 into this, but I could put it into this. So we have to state that 2/3 needs to be excluded. Okay. Any other values? Well, I also, taking a look, I couldn't put a 0 in for an x right there, so it's not going to work for x equals 0. Try it. If I take 0 divided by 3 times 0 minus 2 over 0 divided by 9 times 0 minus 4, we are going to end up with a dividing by 0 in this denominator there, so those are our excluded values. Okay. So that was one method, right? Changing division to multiplying by the reciprocal. I do want to show you the other method for this one as well. So, like we did, okay, we factor right away. Okay. Now let's multiply by the LCD in the numerator and denominator. Now, what is that LCD? Looking at it, it's 3x minus 2 and 3x plus 2, right? It's got to have a 3x minus 2, a 3x plus 2, 3x minus 2, already have it. All right, so when we multiply our numerator here, okay, now remember that this is really over 1. Okay, so the 3x minus 2's cancel, and we have x times 3x minus 2. No, 3x plus 2. Over. Remember that this is really over 1. So the 3x plus 2's cancel, the 3x minus 2's cancel, and we have x. And then when we look at this, the x's cancel, and we have 3x plus 2. And our excluded values were what? 2/3 and 0. Okay. Now, for this problem, I think this method was probably a little bit faster, a little bit easier, okay, than this method. Okay. However, when we look at this one, now what do we have? It's not a fraction divided by a fraction. It's a sum including a fraction divided by a sum including a fraction. So if I wanted to change multiplying to dividing to multiplying by the reciprocal, I would actually have to figure out what this numerator is by adding and subtracting those, and then I'd have to do the same down here, and then change multiplying to dividing to multiplying by the reciprocal. So I think it's going to be much easier on this one to just multiply by the LCD. Now, let me just rewrite this. There's no factoring, but I want to write this just a little bit bigger for everybody. Okay, so what is the LCD? Well, keep in mind, this is over 1, this is over 1, this is over 1, this is over 1. So our LCD has to have 1 go into it. Well, that's simple. It has to have an x minus 4 in it. Okay. And really, our LCD is just x minus 4. Okay, so I'm going to multiply the whole numerator by x minus 4 and the whole denominator by x minus 4. Okay. So let's do it. X minus 4 times x. X squared minus 4x. Minus x minus 4 times negative 1. Minus x, don't forget to distribute the negative, plus 4. Now, what's x minus 4 times 2 over x minus 4? Well, there the x minus 4's would cancel, leaving us with just plus 2. Over. Distribute. X times x minus 4 is x squared minus 4x. Plus 3 times x minus 4, 3x minus 12. And x minus 4 times 6 over x minus 4, the x minus 4's would cancel, plus 6. Okay. Now, sometimes I see students do this. Well, those cancel now, and those cancel now. Okay, we can't do that because there are sums and differences. We can only cancel things out when they are products. All right, so like when I look back at this one, this is x times 3x plus 2, so the x's can cancel out. Okay, but because there are pluses and minuses scattered through there, we can't. But we can combine like terms. Let's see here, x squared minus 5x plus 6, x squared minus x minus 6. Now, I don't know about you guys, but when I look at that one, I wonder if those factor and if anything will cancel out. So, let's see, that's x minus 3, x minus 2. Down here, this is x minus 3x plus 2. Okay, I'm just double checking myself here for a second. Looks good. Looks good. And the x minus 3's cancel to give us x minus 2 over x plus 2. All right, any excluded values on this one? Well, looking at the original function, x cannot equal 4, can it? Okay, so I have to get rid of the 4. X cannot equal 4. Now, x can also not equal negative 2 here. That's not in the domain, but negative 2 also wouldn't be able to go into this. If I were to work through this problem with negative 2, it'd be negative 2 plus 3 is 1. 6 divided by negative 2 minus 4 is 6 divided by negative 6, which is negative 1. So it'd be negative 2 plus 3 minus 1, which makes the entire denominator 0. So they are equivalent at x equals negative 2 in the fact that they both don't contain x equals negative 2. So I don't need to make that. I only need to put the values that the original and our simplified version do not match on. All right, let's look at one more. All right, here we go, big one. Okay, so taking a look at here, first step, we need to factor. This is x plus 6, x minus 6. No factoring to do on this one. And this is x over, let's factor out a 6x. There we go. Now, before I go any further, I do notice that this x and that x will cancel out. So I think it's worth doing that because that'll make our LCD smaller and allow us to do less simplifying at the end. All right, so there we go. What is our LCD? Well, our LCD has to have an x plus 6 in it. Has to have an x minus 6 into it. Has to have a 3x in it. Has to have an x minus 6. Already have it. Has to have a 6. Doesn't have a 6. It has a 3. I'm going to change this 3 to a 6. Notice 3 still goes into 6 and 6 goes into 6, so that's good. And it has to have an x minus 6 into it. Already has it. Okay. Now we also have to multiply that into the denominator. This way we're really multiplying by 1, right? All right, time to distribute. I'm going to take this entire LCD times this fraction. If it's helpful for you to write this LCD next to that fraction, you're welcome to do that. I'm not going to. I can mentally handle this. So when I distribute this in, notice the x plus 6's would cancel, the x minus 6's would cancel, and the only thing left would be 6x. Plus. Now, when I multiply this to that term, notice the 3 and the 6 is going to reduce to a 2. The x's would cancel, and we would still have x plus 6, x minus 6. over. Distribute this to that term. The x minus 6's would cancel. What would be left? Well, we'd still have the 6x. We'd have this x plus 6 along with that x plus 6. Minus, now let's multiply this into that fraction. The 6's cancel. The x minus 6's cancel. So what would be left after things cancel out? An x and an x plus 6. There we go. Okay. So I know that's a lot, but we can work through it. And the nice thing is when you multiply by the LCD over the LCD, it clears all these denominators out. Now it's just one fraction, no more fractions inside of a fraction. And now we just get to work on simplifying. In the numerator, let's multiply. This would be x squared minus 36. This would be 6x times x squared plus 12x plus 36 minus x squared minus 6x. 6x, distribute the 2. Distribute the 6x. $216, I believe. Yep. All right, so 2x squared plus 6x minus 72 over 6x cubed. There's a 72x squared and a negative 1x squared. That's 71x squared. And then 216x minus 6x, 210x. And that looks good. What are the excluded values? Well, notice in the original, x can't equal negative 6 or 0. So those would be our excluded values. Actually, I don't need to put 0 on there because it's clear that 0 also makes this one undefined, so I can get rid of that one. 6 and negative 6, though, would be our excluded values. There we go. All right, so that's complex fractions. Thanks for watching. We'll see you next time.